Second rule is Kirchhoff's voltage rule is the algebraic sum of the product of current and resistance in any part of the loop is equal to the algebraic sum of the EMF that is included in the circuit. So Wheatstone bridge is a direct application of these two rules. It's a network which is used to find the unknown resistance. Okay, so it is an arrangement where you find an unknown resistance. There are 4 resistors which are connected. So it applies Kirchhoff's loop rule, and then it gives you the values of unknown resistance in a network. And here it works on the principle that once the bridge balance condition, it works on bridge balance condition. What do you mean by bridge balance condition is when 2 points are at the same potential, will current flow through it? No. If 2 points are at the, what is the reason for flow of current? Potential difference. Suppose there is no potential difference, then naturally current should not flow across that particular branch. So it makes use of this particular principle, and that is called as bridge balancing condition. So the network is like this. You can either write it as PQRS or R1, R2, R3, R4, whichever you take. Suppose you are taking as PQRS, your answer will be, in the book they have taken as R1, R2. So we will go with this itself. Okay. So it is a direct application. Now this is your circuit diagram. Those who have the book, they can have a look at the book itself. Now, so this is how the network is connected. There are 4 resistors, R1, R2, R3 and R4. Now, what are the junctions here? Which are the 4 junctions here? A is a junction, B is another junction, C, and you have D. Now here, the EMF is connected here at the end, and the current starts flowing from the positive terminal, higher potential, to the lower potential. So the current will start flowing from here. Let the current be I. Now at the junction A, what happens? The current splits into 2 components, I1 and I2. If I1 is the current flowing through R1 and I2 is the current flowing through R2. Now what happens after I2 reaches the junction B? It again splits into 2. One will flow through this galvanometer. Let it be IG. Let the current flowing through the galvanometer be IG. Another part, I4, flows through the unknown resistance R4. Okay. Now, what happens at junction C? This I4 meets at the junction C, and here this IG and I1 together flow as I1 and IG flow together as what? Which current? They join together to form I3, and it flows to the junction C. So here, suppose I is the current here, it splits into 2. I splits into I1 plus I2. Again then I2 splits into 2. I4 plus IG. Then I4 and IG meet together at the junction D. What are the currents which are meeting at the junction D? Tell me. What are the currents entering the junction, and what are the currents leaving the particular junction D? I1 and IG is entering the junction. So the current entering a junction is always taken as, and the current leaving the junction is taken as negative. So I1 plus IG minus I3 equal to 0. According to Kirchhoff's junction rule or current rule, the total current entering a junction is equal to the total current leaving the junction. So I1 plus IG minus I3 is equal to 0 as far as junction D is concerned. Similarly, what will be the equation for junction B? What will be the equation for junction I2 minus I4, I2 minus I4 minus IG equal to 0. Now these are the 2 junctions where you apply KCL, or the junction rule you will apply. So what are the 2 equations? Tell me. First equation is I2 minus I4 minus IG is equal to 0, and I1 plus I2 minus I3 is equal to 0. Now go for the loop ABCD. Go for the loop ABCD. Now apply KVL. KVL, if you apply, what will you get? The current flowing through the resistance, the product of current and resistance will be equal to EMF. Do you have any EMF in the loop ABCD? No, you don't have. So you will equate it to 0. Very good. Now tell me, by convention, you take it in a cyclic order. So If you're going from A1, I2 will be positive, I4 will be positive. What about I3? Negative. You're opposing the current. The direction of current is opposing to the direction that you have taken, the loop. So tell me the equation for this particular loop, A, B, C, D. Can you tell me? Applying I2, I2, I2 into R2, yes, plus I4 into R4 minus I3 into R3 minus I1 R1 equal to 0. So what are the three equations that you got? Two equations you got from the junction rule and one you got from the loop rule, KVL. So here I1 plus Ig minus I3 is equal to 0 and I2 minus I4 minus Ig is equal to 0. Similarly, I2 R2 plus I4 R4 minus I3 R3 minus I1 R1 is equal to 0. Now you apply the bridge balancing condition. Now the current, you adjust the value of current and resistance such that the points B and D become at the same potential. You will vary the resistance or you will vary the current. Okay, you will vary the current and finally what happens? The B and D, they appear at the same potential. So which current will vanish? Because B and D are at the same potential, the current will not flow through the galvanometer. So Ig will disappear. Suppose there is no Ig in the equation. Now what will be the new equation? I2 minus I4 is equal to 0, which means I2 is equal to I4. Similarly, I1, are you listening all of you? I1 minus I3 is equal to 0, which means I1 is equal to I3. There is no loss of current. The I2 which flows through this particular branch, there is no loss of Ig and it appears as I4 itself. There is no loss in current because there is no side flow of current through the galvanometer. Clear? So I2 will be equal to I4. Similarly, I1 will be equal to I3. So I1 will flow as I3. There is no addition of Ig. Then one more. Here, similarly taking, now take this particular loop, that is A, B, D, A. Take the loop A, B, D, A. Can you apply the KVL and tell me the equation for A, B, D, A? I2, R2, no, go for that loop also. Then we will apply Ig is equal to 0. Complete the loop, start from A, go to B, reach D and then you have the loop. First you write with Ig itself. Then we will go for, yes, plus Ig into capital G, where capital G is the resistance of the galvanometer. Then minus I1 R1 is equal to 0. Here also you apply the bridge balancing condition, Ig is equal to 0. So you get I2 R2 is equal to I1 R1. With these three equations you will apply here. So I1 is equal to I3, correct? I1 is equal to I3. So I1 is, here it was I4 R4 minus I3 R3 minus I1 R1. So here you will apply I1 is equal to R1. So what can you take common here? I1 or I3, whatever you want. We will write it as I1 itself. So here you will take I2 as common. I2 into R2 plus R4 you will write. Then take the negatives to the right hand side. So you will get, take it as I1. I1 into R3 plus R4. I1 into R3 plus R1. Now, divide this side by I1, I2 R2. One side you can divide by I2 R2, the other side you can divide by I1 R1 because I2 R2 is equal to I1 R1. From this equation we find that I2 R2 is equal to I1 R1. So this side you can divide by I2 R2, the other side you can divide by I1 R1. I1 gets cancelled, I2 gets cancelled. Then R2 by R2, that is 1 plus R4 by R2. The other side you get 1 plus R3 by R1. 1 gets cancelled. So R1 by R2 is equal to R3 by R4. Cross multiply. You get R1 by R2 is equal to R3 by R4. I'll write here. So what were the equations? If you have the, shall I write here? Okay, what were the equations that we got? Look into your loop and tell me the answer. First, apply KCL to junction B. What was the equation? Look at junction B and tell me the answer. What is the current meeting at the junction B? Which are the currents entering the junction and which are the currents? See, first you have to draw the diagram. Then you have to apply KCL to junction B. Then you apply Kirchhoff's current rule to junction D. From junction B, tell me the answer. Yes? I2? No, it is junction rule, ma. I2 minus? What is the current entering at the junction B? I2 is entering. I2. And what is the current leaving the junction? IG and I4. So you will write I2 minus IG minus I4 is equal to 0. Correct? Take it as equation number 1. Similarly, apply KCL for junction D. Tell me the answer. What is the current entering the junction? I1 is entering the junction. Plus IG because IG is meeting. Minus I3 which is leaving the junction is equal to 0. The algebraic sum of the current entering a junction will be 0. Clear up to this? Any doubts? Now you have taken loop rule for A, B, C, D. A, B, C, D. What was the equation? A, B, C, D. I2, R2. Plus I4, R4. Any doubts, ma? Then tell me. Minus I3, R3. Minus I1, R1. Is there any source of EMF in the loop that you have taken? A, B, C, D, A, B, C, D, A. No, you don't have any source of EMF. So that should be equated to 0. This is equation number 3. Then what is the loop that you took? A, B, D, A. Lohit, tell me. Apply Kirchhoff's loop rule to A, B, D, A. And tell me the answer. A, B, D, A. Look into the diagram. B and D are at the same potential. As a result, what happens? No current flows through the galvanometer. So wherever you have Ig in the equation, it will become 0. Now tell me what happens to equation number 1, 2 and 4. 1 becomes I2 is equal to I4. If you look into that diagram, you find that if I2 is entering the junction B, there is no loss of current through galvanometer and the whole current I2 flows as I4. Similarly, I1 is the current which is entering the junction D, right? D, and there is no addition of Ig, there is no current through, and there is no addition of Ig, there is no current through galvanometer, so that flows as I3. Then from this equation you get I2 R2 is equal to I1 R1. Here, so instead of I4 I can write I2 itself. So I'll take it as I2, and if I take it as common, R2 plus R4, which is equal to this side, take the negatives to the RHS. I1 and I3 are same. Let us write it as I1 itself. I1 into R3 plus R1 or commutative property, R1 plus R3, whatever. Okay, then this side you will divide with what? I2 R2. The other side, RHS, you will divide with I1 R1. So what will you get? I2 gets cancelled. R2 plus R4 divided by R2 is equal to I1 gets cancelled. R3 plus R1 divided by R1. R2 by R, you have to separate it as common. R2 by R2 plus R4 by R2. So you will get 1 plus R4 by R2. Similarly, what will you get here? R3 by R1 plus 1. So 1 gets cancelled. If you rewrite, you can write it as R1 by R2 is equal to R3 by R4. If you want, you can compare the resistances, or you can also find the unknown resistance provided you're given 3 known values. If R1, R2 and R3 is given, you can find the 4th unknown resistance. So this is the advantage or use of Wheatstone bridge. Once again, so Wheatstone bridge is used to compare the resistances or find unknown resistance. The diagram is shown. It is an application of, it applies which rule? Kirchhoff's loop rule and Kirchhoff's junction rule. So across one pair of diagonally opposite points, the source is connected. So, and what is the bridge balancing condition? Under bridge balancing condition, the points B and D become at the same potential. As a result, no current flows through the galvanometer, hence Ig is equal to 0. So what were the equations that you got? What were the equations that you got? Here after, before applying, that equation is not given. If you want, you can write applying to junction B and D. It's given in the textbook or not? I1 is equal to I3, I2 is equal to I4. You understood how we got all this? Huh? Now write, shall I dictate? First you draw the diagram. Put today's date. Draw the diagram. Draw the diagram. To draw the Wheatstone bridge diagram, circuit diagram. Shweta, finish drawing? Shweta Karthikeyan. 3 arm. Between the other two vertices, between the other two vertices B and D, between the other two vertices B and D, a galvanometer capital G, a galvanometer capital G is connected. A galvanometer capital G is connected. Hence, the line BD is called, the galvanometer arm, Now, if you consider that the cell has got some internal resistance, you have to take that also into consideration. For simplicity, what do? We take that the cell has no internal resistance, so that we don't complicate the circuit very much. That is one assumption that we take, that the cell doesn't have any large value of internal resistance. In general, the currents flow, the current flows through all the resistors and the galvanometer. In general, the current flows through all the resistors and the galvanometer. in the case of balanced bridge condition, in the case of balanced bridge condition, in the case of balanced bridge condition, comma, the terminals B and D, the terminals B and D, the terminals B and D are at the same potential. The terminals B and D are at the same potential, and hence no current flows through the galvanometer, and hence no current flows through the galvanometer. You don't have that line here, right? No current flows through the galvanometer. That is, Ig is equal to 0. That is, Ig is equal to 0. Now start writing. Applying Kirchhoff's junction rule, applying Kirchhoff's junction rule, applying Kirchhoff's junction rule to the point B or to the junction B. Applying Kirchhoff's junction rule to the junction B, we get, tell me, junction B, B. We get, tell me the equation, I2 minus Ig minus I4 is equal to 0. I2 minus Ig minus I4 is equal to 0. Write it as equation number 1. Applying Kirchhoff's junction rule to junction D. Applying Kirchhoff's junction rule to junction D. Tell me the equation. I1 plus Ig minus I3 equal to 0. I1 plus Ig minus I3, clear? Yes, Praveen. You have any doubt? Junction D ma. B repeat pannuma. So B la edha enter agudhu? I2 enter agudhu. Ig enter agudha? I4 enter agudha? I4 is leaving the junction. I2 alone is entering the junction. Yes, ma. So I2 is entering the junction. Ig and I4 is leaving the junction. Yes, Praveen. Clear? So B la varumbodhu I2 minus Ig minus I4 is equal to 0. Yeah, I'll repeat, ma. Please wait. For those who are online, I'll repeat. Now, yes. Ig oda direction. See, I2 inga pogudhu. I4 is leaving the junction. So, in the I2 la oru portion I4 a poguduna, meedi irukra portion, that is I2 minus I4 should definitely flow through Ig. Appadithana poirukano. See, this is positive potential. B is going to be at a higher potential than D. Correct? Inga positive is connected. So, A is at a higher potential. Similarly, C is at a lower potential. Now, current inga enter aguduna, I2 and I4. Now, here B is at a higher potential than D. Adanala dhan B la irundhu D ki flow agudhu. Okay, that is why it is flowing through. The positive potential, now the flow will be like this. So that is why. Galvanometer actually direction, it doesn't have positive negatives. It only detects the direction of current. Okay, the current B is at a higher potential than D. That is why current flows through from D to B. Now, D edhiyacha. Now, applying Kirchhoff's voltage rule to the loop. Kirchhoff's voltage rule to the loop. Solluma, end the loop. A, B, C, D, A. Applying Kirchhoff's voltage rule or loop rule to the loop A, B, C, D, A. Yeah, tell me. A is at a higher potential. I2 R2 plus I4 R4 minus I3 R3 minus I1 R1 is equal to 0. That is equation number 3. You got equation number 1, equation number 2, equation number 3. Now one more loop you will take. You will take A, B, D, A. Applying KVL to the loop A, B, D, A. Applying KVL to the loop A, B, D, A. You get I2 R2 why? Plus IG RG minus I1 R1 is equal to 0. Write it as equation number 4. Right, applying bridge balancing condition to equation 1, 2 and 4. Applying bridge balancing condition to equation 1, 2 and 4. Do you have any doubts? I2 R2 plus IG RG minus I1 R1 is equal to 0. Applying bridge balancing condition to equation 1, 2 and 4, we get, what are the equations that you get? Suppose you put Ig is equal to 0. What will you get? I1. Tell me, I1 is equal to I3, then I2 is equal to I4, and similarly I2 R2 is equal to I1 R1. So you can write it as equation 5, 6 and 7. You can write it as the new equations as 5, 6 and 7. Then applying 5, 6 and 7 to equation 3. Applying equation 5, 6 and 7 to which equation? Equation number 3. What is equation number 3? Yes. You split it into two parts. Take all the negative terms to the right hand side. So what will you get? I2 R2 plus I4 R4 is equal to okay. So if you apply that I2 and I4 are same, you can write it as I2 into R2 plus R4 is equal to I1 into R1 plus R3. Sorry, R3. Yes. Now what was that equation? I2 R2 is equal to I1 R1. What is the number that you gave? 7. Yes. Dividing both sides by equation 7. Dividing both sides by equation 7. Dividing both sides by equation 7. Yeah. Complete the calculation and rearrange. What is the final equation that you get?
R2 by R1 is equal to R4 by R3.
R2 by R4 by R2 is equal to R3 by R1, or R1 by R2 is equal to R3 by R4. Are you arriving at this equation? All of you?
Yes, ma'am.
Dishita, you got? Pratap,
Yes, ma'am. Yes, ma'am.
Deepajyoti, Saravanan, Varshita Shri. Kavya, you got? Yeah. Kavya. So R2 by R1 is equal to R4 by R3, or rearrange. So you can calculate the unknown resistance. Here, which one is the unknown resistance here? R4 is the unknown resistance. So R4 is equal to R3 into R2 by R1. Now try to solve example 3.7. And what have they asked to find out? A galvanometer of 15 ohm resistance is connected across B and D. Calculate the current through the galvanometer when a potential difference of 10 volt is maintained across AC. They have not applied bridge balancing condition. They have asked you to take a loop and using KVL you are going to solve this. Okay. So which mesh? You can take any loop of your choice wherever you have IG. Okay. Whichever loop you want you can take. You can take A, B, D, A or B, C, D, A you can take, or even A, B, C, D. Then what are the unknowns? I1, I2, only two unknowns you have, three unknowns you have, I1, I2 and IG. So how many equations you require? How many unknowns are there? Three unknowns. So how many equations you require? Three equations you require. You can take any mesh, any loop that you have. So they have taken BA, DB. Now take BA, DB. Tell me the equation for BA, DB. Starting from B. Minus 100 I1. Then plus 60 I2 minus 15 Ig equal to 0. Okay. Then you can divide it by 5 and simplify the equation. Then they have taken B, C, D, B. They have started from B. B, A, D, B. Current is opposite.
Current is A to B, right?
Yeah, but we are taking from B to A. Yeah, that is what we have taken now. They have taken, even if you take it as minus 100, and then what will you have here? This will be minus 60 and this will be, the negative sign will change, no? Suppose you are writing as minus 100 I1 plus 60 I2 minus 15 Ig equal to 0. If you multiply the whole equation by negative, so it will come 100 I1 minus 60 I2 plus 15 Ig equal to 0. You can multiply the whole equation by negative. Okay. So that is how they have taken 60 alone as negative and 100 I1 and 15 Ig is positive. Now they have taken B, C, D, B. B, C, D, B. Tell me the equation. 10 into 10 into 10 into I1 minus Ig, B, C, D, B, isn't it? Minus 5 into I2 plus Ig minus 15 Ig equal to 0. So check for the equation. Correct? Now, then A, D, C, E, A. Any three equations you can take. Try solving. You need not always take this particular loop. Whichever loop you take any three equations where you get I1, I2 and Ig. So they have taken A, B, C, E and A, correct? A, B, A, D, C, E, A, D, C, E, A, D, C, E, A, D, C, E, A. This one, na? Correct? A, D, C, E, A. Tell me the equation. I2. Tell me the equation. I2, 60 I2. Then plus 5 I2 plus IG. Then, yeah, that's all. Is equal to, when you're moving in this direction, you're moving from the negative potential to the positive potential. So you will take it as positive or negative? Positive. So that is equal to 10 volt. Check for the equation. Check whether that equation is written. Increase the temperature. Yeah, what is the equation that you got? And try solving it. I1, I2, IG. Yeah, solve it and find out the answer. Now, shall we do some numericals in Kirchhoff's junction rule? And you people, you need the notes, online students. Shall I send you as a PDF? I'll post it. No need to waste the time. So, in the question, if R1 is 2 ohms, R2 is 4 ohm, R3 is 6 ohms, determine the electric current which flows in the circuit given below. Apply KVL to the loop. There is only one loop here. So, yes. Okay. So, they have written as R1, R2, R3, then they have substituted the values. 9 minus 3 is equal to 0. You understood? You have copied down this question? Copy down the circuit. You copy down the circuit, all of you? Enama? எப்படி இருந்தாலும் ஆன்சர் கடைசியில் பாசிட்டிவ் வரணும். ஓகே, மைனஸ் கரண்ட்னா ஒன்றுமே இல்லை, நீ எடுத்த டைரக்ஷனை ரிவர்ஸ் எடுத்துக்கணும். பை கன்வென்ஷன் வாட் எவர் யூ ஹவ் டேக்கன், இஃப் யுவர் ஆன்சர் இஸ் கமிங் இன் நெகட்டிவ், நீ எடுத்த டைரக்ஷன் லைக் 9 வோல்ட் தான் அதிகமான கரண்ட்டை கொடுக்க போகுது. இந்த 3 வோல்ட் ஒப்போஸ் பண்ணால் கூட யாரோட ஃப்ளோ தான் அதிகமாக இருக்கும்? 9 வோல்ட்டோட தான் அதிகமாக இருக்கும். தீஸ் டூ ஆர் நாட் இன் சீரீஸ். ஓகே, தே ஆர் ஒப்போசிங் ஈச் அதர். 9 வோல்ட் இந்த டைரக்ஷனில் கரண்ட் கொடுக்கும் ஃப்ரம் ஹையர் பொட்டன்ஷியல் டு லோவர் பொட்டன்ஷியல். பட் 3 வோல்ட் வந்து அதை ஒப்போஸ் பண்ணும். ஓகே, எந்த டைரக்ஷன் எடுத்தாலும் answer you are going to get the same. So you have copied this diagram, circuit diagram. You got the answer? Now next question. யஷ்வந்த் எழுதுறியா இல்லையா? போர்டை பார்த்து எழுது, எதுக்கு பக்கத்தில் இருக்க அவனை பார்த்து எழுதுற? Did you copy? Pavitra finished, huh? Kirti, Mithun, Deepa Jyoti, Shaktivel.
Yes, ma'am. Now, could you go back for a minute? 1 second.
Yes. சார் அந்த நோட் ஃபைல் சரியான டயக்ராம் கொஸ்டின் கீழே வரல பாருங்க. நோட் ஃபைல் அடுத்தது பாருங்க. ஆ அதில் நீங்கள் கரெக்டாக தான் போட்டிங்கண்ணா. அடுத்த ஸ்லைடு கொஸ்டின். இங்கே இந்த ரூம் ஓப்பன் ஆகல. சார் அந்த கீ கொடுங்க, கீ. எஸ் எஸ். So here find the current, same. Same direction you take. 20 volt. You're going from positive to negative, so you will take it as minus 20, then 5i. 5i into plus 10i minus 12. Minus 20 minus 5i minus 5i minus 12 minus 10i is equal to 0. So minus 32 minus 20i is equal to 0. Minus 32 is equal to 20i. I is equal to minus 32 by 20. Since the answer is negative, it means that the direction is actually anti-clockwise. We have taken it as clockwise, so the correct answer is it flows in the anti-clockwise direction because this is your positive potential. 20 volt or positive potential in the anti-clockwise. How did we start? By convention, we took it as clockwise. So the correct flow is anti-clockwise direction. நம்ம எடுத்தப்போ நமக்கு நெகட்டிவ் வருது. So circuit current எப்படி flow ஆகுது? Not in the clockwise direction but in the anti-clockwise direction. Yashwant, are you writing? You have taken the diagram? Okay, let's go for the next one. Determine the electric current that flows through the circuit as shown. Same. Make it fast. volt anti clockwise எடுத்தீங்கன்னா கரெக்டாக தான் வரும், பாசிட்டிவாகவே வரும். ப்ளஸ் 12 1i ப்ளஸ் 6i ப்ளஸ் 12 ப்ளஸ் 25i. இது 25 இல்லை சாரி, இது 2 ohms, 2 not 25, 2. Ah, 2.6, 2.66. So this has been asked for 3 marks. Very simple. Applying KVL. Shall we go for the next one? Yeah, here. Ha. இதில் எப்படி effective resistance கண்டுபிடிக்கிறது? R1 R2 எல்லாத்தோட values கொடுத்திருக்காங்க. R1 and R2 are parallel to each other. So how will you find the value of R1 R2 effective resistance? 1 by R1 plus 1 by Rp is equal to 1 by R1 plus 1 by R2. That is 1 by 12 plus 1 by 12. So 2 by 12, 12 by 2, 6. In the full effective, in a single resistance போட்டு you can reduce the circuit. இந்த 12 12 சேர்த்து parallel இருக்கிற ரெண்டனத்துக்கு பதிலா என்ன போடலாம்? 6 ன்னு effective போட்டுடலாம். புரிஞ்சுதா? அந்த calculation காட்டணும். அந்த calculation காமிச்சிட்டு இங்க 6 volt. Then R3 R4 லாம் கொடுத்திருக்காங்க. R3 is given, R4 is given. Take clockwise or anti-clockwise any direction. So இங்க மட்டும் தான் ஒரு சின்ன சேஞ்ச் வருது. இந்த ரெண்டோட effective resistance கண்டுபிடிச்சிட்டு reduce it as 6 ohms. Nikhil, are you writing? Huh? Parallel எது? அது capacitance. Resistance க்கு 1 by Rp is equal to 1 by R1. Resistance க்கும் capacitance க்கும் மாறும். What happened? E1 is 6 volt and E2 is 12 volt. You can take it in the anti-clockwise direction. You can take the current as anti-clockwise direction. Start from the positive and then ingo 6I. Then here you are moving from positive to negative. So E2 என்னவா எடுத்துக்கணும்? Negative எடுத்துக்கணும். Then R4 எவ்வளோ? 6I plus 3I. And find out the value. You got? Write the unit also. I. Take down the values. Finished? You took it in the clockwise direction or anti-clockwise direction? Anti-clockwise. E1 பெருசா E2 பெருசா? E2 தான் பெருசா. Okay. Finished? Now determine the electric current flowing through this particular circuit. Can you see the values? This is 10 ohms, 6 ohms, 8 volt, 5 ohms, 20 ohms and this is 12 volt. Direction avanga kudukala, you can take. Can you see the values? 10 ohms. So first you will find the effective resistance between 20 ohms and 5 ohms which are connected in parallel. So the answer is 1 by 20 plus 1 by 5. So 25 by 4. So which direction are you going to take? Clockwise or anti-clockwise? Clockwise because 12 volt இது எடுத்துக்கலாம். So 10I plus 6I minus 8. Here you said 4 la, 4I plus 12 volt is equal to, how much did you get? Finally, how much you got? 1 by 5, yeah? 0.2, 1 by 5, 0.2 ampere. Finished? Now determine the electric current that flows. This is 1, this is 6 volt. You want the answer or question? Okay, வேற ஏதாவது எடுக்கலாம். We'll take some other. Okay, I'll give you another one. Finished? சரி, வேற ஒன்று தரவா? Draw this diagram. Draw this diagram. I'll give you the values. Please draw. This is 1 ohm, 5 ohms, 10 ohms. Here it is 5, 25, 20. Place இல்லை என்னால் ஓம்ஸ்னு போடல. 15, 1 minute. Here the resistance 5, 10, 15 and 30 forms a balanced Wheatstone bridge. Here. Okay, you have drawn the diagram. Find the equivalent resistance between the points A and B for the network. Resistance மட்டும் தான் கேட்டிருக்காங்க, current கேட்கல. Effective resistance கண்டுபிடி. எதாவது series, எதாவது parallel னு பாரு. Find the total resistance, effective resistance. இந்த ஒன்று பிரச்சனை இல்லை, இதை தான் நீ சால்வ் பண்ணணும். That one will be in series with இதுக்குள்ள இருக்கிற ஃபுல்லும். எங்க ஜங்ஷன் எது parallel, எது series பாரு. Got an interesting question? You got an interesting question? Take your own time. Huh? இல்ல, you solve. எது சீரீஸ் எது parallelனு think and yes. Does it look like a Wheatstone bridge? The combination of 5, 10, 30 and 15. Does it look like a Wheatstone bridge, balanced Wheatstone bridge? Yes. Then what we will do is, idla current flow agala nanachipom. If that is balanced, no current will flow through this particular branch. Okay, current வந்து இப்படி flow ஆயிடும். If it is balanced, no current will flow through 5 and 10. So 5 and 10 can be eliminated. If it is balanced, இங்க enter ஆகிறது B க்கு போகும் and this is balanced condition. So என்ன இருக்காது? Sorry. Now it is a bit simplified. Here you have 1, here you have 5, here you have 10, then here you have 25 and 20, then you have 15 and 30. So 5 plus 10, 15, 45, then 45 again. 3 parallel இருக்கு. 10 and 10 and 1 is in series. So the final answer is a final you got 10. Okay, இது எவ்வளவு வந்தது? 1 by 15, 1 by 45, 1 by 45, 9 வருது. So 1 by 45 plus 1 by 45 plus 3 by 45. So 5 by 45, 45 by 5, 9 ohms வருது. And 9 ohms is in series with 1 ohms. You want one more question from this? This anyhow sir will be giving you this book. Notes also you have, short notes you have. Okay, one more loop I will give you. Very interesting loop. Book irka? He will give you, distribute for everyone. This you have 20 years CBSE questions. Previous 20 years of the topic wise and lesson wise. Okay, shall I give you this? I'll draw here. Two ohms. This is what was asked for the CBSE exam previous year. Okay. Then 4 ohms, 2 ohms. They have given the direction of current also. This is I1. Since this is a junction, there is a split of current. This is I1 and this is I minus I1. Here you have a cell, 6 volt, positive and negative. Then you have I1 flowing through this branch. Here you have a 2 ohm resistance. Then here you have a cell, 6 volt, and the current flows in this direction. What will be this current? I. Okay. Solve. Yes. Devadarshan. Yes.
And the right side of the 6 volt kilo resistor adike evlo value?
Resistance 2 ohms.
Okay. Okay.
You are supposed to calculate I1, I and I1, I1, I2 illa I1. Current through all the branches. That is I and I1 you have to calculate. Only 2 unknowns, any 2 loop you can take. One full loop எடுக்கலாம் இல்லனா break வர அந்த சின்ன சின்ன loop எடுக்கலாம். Anything you can take. Find I and I1. Your choice. You can take any loop. Yeah, you people will work out and tell me the answer, online students. Ivan, are you there?
No.
Mithun, Kirti?
It's not.
Yes. Shaktivel? Shaktivel? Shaktivel, are you there? Solve and tell me the answer. I and I1. Calculate. Any loop. Yashwant, are you doing or not? எந்த loop எடுத்த Yashwant? எந்த loop choose பண்ண? You can give any names. A, B, C, D. I1 0.6. No. Mrityunjay, எந்த loop எடுத்த? AB? AB. B, C, D, E, B. Okay, எடுத்த. வந்ததா ரெண்டு equation?
One equation is 6i minus 4i1 minus is equal to minus 3. Another equation is 6i1 minus 2i equal to 0.
Yes. Yes, Devadarshan.
Ma'am, I is equal to 0 and
I is equal to?
0.
இல்ல இல்ல I 0 எப்படி வரும்? I 0 ஆச்சுனா கரண்டே ஃப்ளோ ஆகலன்னு ஆயிடும் இல்லையா? 0 point what?
I1 வந்து பார்த்தா I1 வந்து பார்த்தா 0.85.
0.85 ஆ? Okay, then I எப்படிமா 0?
இங்க வந்து
சரி எந்த equation சொல்லு நீ?
6i minus 4i1 equal to
நீ A B E F தானே முதல்ல சொன்ன. A B E F. So 6i sorry 2i
plus 4i.
2i then plus 4 into I minus I1 அப்புறம் minus 6 volt plus 3 is equal to 0. So 2i plus 4i minus 4i1 minus 3 is equal to 0. Correct? So 6i minus 4i1 is equal to 3. This is one equation. இன்னொன்று எது எடுத்த? B, C, D, E. அதுக்கு என்ன வரும்? 2i1 சொல்லுமா? minus 6 positive to negative 6 volt battery அப்புறம் plus 2i1 இதுவும் i1 தான் 2i1 அப்புறம் plus 6 அப்புறம் minus I minus 4 I minus I1 equal to 0. Plus 6 minus 6 cancels. 2i1 4i1 வருது. Then minus 4i plus 4i1 equal to 0. Correct? So 8i1 is equal to 4i. 8i1 is equal to 4i. So I வர இடத்துல என்ன substitute பண்ணலாம்? 2i1 போடலாம். I வர இடத்துல 2i1 போடலாமா? So 2i1 போட்டனா இங்க என்ன வரும் 12i1 minus 4i1 is equal to 3. 12 minus 4 is 8. 8i1 is equal to 3. So i1 is equal to 3 by 8. 3 by 2 வருதா 6 இது 12 தானேமா அதான் தப்பு பண்ணிட்டேனா இது கரெக்ட் தானே இந்த லூப் 2i1 correct minus 6 plus 2i1 again plus 6 minus 4 into I minus i1 is equal to 0. So 2i1 plus 2i1 is 4i1 minus 4i plus 4i1 is equal to 0. So 8i1 is equal to 4i. 8i1 is equal to 4i. Or i1 எடுத்தனா 0.5i னு வரும். Anything you can substitute. I is equal to 2i1. I is equal to 2i1. 6i
minus 4i1.
6i. 2i1. Okay.
Then 12i1 minus 4i1 equal to
minus 3.
voltage will be after equal.
இந்த லூப்ல minus 3 தப்பா எடுத்துட்டோமோ பாசிட்டிவ் நெகட்டிவ் டு பாசிட்டிவ்
That will be after equal.
ஓகே ஓகே
So it will be minus.
equal to minus 3 இல்லையா
Then 8i1 is equal to minus 3.
minus sorry where எந்த லூப்மா or go for the bigger loop a c d e f அது பாரு அது என்ன வந்தது
8i minus 4i is equal to 0.
8 ஐயா
Which one?
பெரிய லூப் எடு a b c d e f a b f g a see 8i minus 4i1 plus 3 equal to 0 அது வருதா ஒரு equation 8i minus 4i1 plus 3 equal to 0 you got that equation anybody when you took this loop இந்த loop எடுத்தியா 1 அதுக்கு என்னமா equation வந்தது
Ma'am, 8i minus 4i.
8i minus 4i1
Ma'am, that will be the next BC,
a b f g a இதுதான் அவங்க போட்டுருக்காங்க அவங்க புக்ல a b e f a that will be
6i minus 4. We can't.
see this is 2i and this is 4 into I minus
We got that.
Ma'am, we got that. Ma'am, 6i minus 4i1 is equal to minus 3.
plus 6 ಹೋಗ್ಬೋದು
Ma'am, AB. Ma'am, AB, EF, A. That will be 6i minus 4i1 is equal to minus 3, ma'am.
oh I'm so sorry இங்க ஒரு 2 ohms விட்டுட்டேன் நான் sorry அதான் 2 இப்போ போடு இங்க ஒரு 2 ohms இருக்குமா இப்போ பாரு இப்போ பாரு i1 யஷ்வந்த் எந்த லூப் எடுத்த ab சொல்லுமா ab ab ef a tell me the equation போர்டை பார்த்து சொல்லு நோட்டை பார்க்காத சொல்லு சீக்கிரம் 2i1 a b e f a தானே சொன்னேன் so 2i plus tell me fast plus 4 within brackets I minus I1 then minus 3 நீ எழுதுறியா இல்லையா? டெல் மீ தி equation. இல்லைன்னு அவ்வளோ ஹார்டா இருக்கு. போர்டு பார்த்தே சொல்லலாம் இல்லையா? சொல்லு.
அண்ணா சும்மா பேருக்கு லாகின் பண்ணிட்டு
2i plus 4 into I minus I1. Then this is from positive to negative. So 6 volt positive or negative? You're moving from positive to negative. So minus 6. Then yes, ma. Huh? இங்கே போடுறோம்னா equal to 6 0 வரும். இல்ல இந்த பக்கம் போடுறோம்னா பாசிட்டிவ்ல இருந்து நெகட்டிவ் போறோம். நெகட்டிவ்ல இருந்து பாசிட்டிவ் போறதுனா தான் பாசிட்டிவ் வரும் சார். ஆமா -6 தான் போட்டிருக்கேன். -6 then plus 2 into இந்த பிரான்ச்ல என்னமா கரண்ட்? இந்த I minus I1 உம் I1 உம் சேர்ந்ததுனா இங்க என்ன வரும்? 2 should be multiplied with I minus I1 or I. இந்த பிரான்ச்ல Iங்கிற கரண்ட் தான் flow ஆகும். Now you are moving from negative to positive. So plus 3 equal to 0. இது நம்ம equation வந்தது. 2i plus 2i is 4i. இங்க ஒரு 4i இருக்கு. So total 8i minus 4i1 minus 3 equal to 0. Yes. Yeah, Devadarshan.
I is equal to -1.
I is equal to
minus 0.5.
0.5 ampere. Correct. Minus?
Minus 0.7.
Minus. Okay. I வந்து minus 0.5 ampere. Correct? 5 by 2 or 0.5 by 2? 5 by 2 or 0.5 by 2? Check. 0.5 by 2.
0.5 by 2.
Yeah, 0.5 by 2. So 0.25 ampere னு வரும். ரெண்டுமே நெகட்டிவ்ல வரும். ஐயும் சரி I1 சரி ரெண்டுமே நெகட்டிவ்ல வரும். 0.5 amp and 0.25 amp. Pavitra, are you working out? Minus 0.5 amp இது I. See, check your answers. I is minus 0.5 ampere and I1 is minus 0.25 ampere. Any doubts you have? You can take any loop of your choice. One more loop. Just last one. இதெல்லாம் சிம்பிள் தான். 1 mark. Okay, shall I? எதுமா? This one ah? வெறும் ஜங்ஷன் தானே? Normal addition. 0.2 is taken as positive. 0.4 is taken as negative. 0.6 is positive. 0.5 is negative. 0.7 is again positive. I1 is taken as negative. Add everything. Mindly calculate பண்ணிடலாம். 0.2 add பண்ணணும். 0.6, 0.8 ஆச்சு. 1.5 ஆச்சு. 1.5 ல இருந்து 0.5 போச்சு. 1 ல இருந்து 0.4, 0.6 You got 1.5. 1.5 ல இருந்து 0.5 போச்சு. Then you have 1. 1 ல இருந்து 0.4 போச்சுனா 0.6. 0.6. Okay, next loop. 80 volt. 20 ohms. Any other value I didn't write? This is 80 volt. This is 20 ohms, 40 ohms, 10 ohms. This is 40 volt. Here the current is I1. Then here it is I2. I1 minus I2. Then I2 again joins here. I1 minus I2, I2 same, again it goes as I1. Calculate I1 and I2. Yes, Praveen. Code really? Code. இல்ல whole number தான். You got? Huh? 14 14 28 by 7 பாரு 4 यशवंत कुमार போடுறே இல்லையா? Both you are getting 4 amp 4 amp equal, which means what? In the branch la current flow agadu. I1 minus I2. Yeah, both are 4.
I1, I2, 4.
Yes, both are 4 ampere. I1 is 4 ampere, I2 is also 4 ampere. Yeah, try this one. You got? என்னாச்சு? எந்த லூப் எடுத்த? Okay, this one எடுத்தனா 20 I1 okay. அது 80 8 இல்ல 80. இல்ல plus 80 is equal to 0 தானே? Plus 80 equal to 0. Not equal to 80 ma. Plus 80 equal to 0 போடு. அதான் தப்பு. So next one. Then what are you getting? Yes, sir. Can you see the values? This is 6 volt, 2 ohms, 9 volt, 1 ohms, 3 ohms, 3 ohms, and this is I1. யஷ்வந்த் இப்போ நோட்டை செக் பண்ணுவேன், எல்லாத்தையும் முடிச்சு வந்தால் தான் வீட்டுக்கு போவேன். Harvish, you got the answers? Harvish?
Yes, ma'am.
I1 2 ampere, I2 -1.
I1 is? I1 is?
I1 2, I2 is -1.
You are getting it in decimals.
Same equation, ma'am.
Huh.
But how it will come in decimal?
என்ன equation வந்தது உனக்கு? 5I1.
Same equation, both the equations same. I multiplied first equation into 4.
This one into 4 you did, okay.
20 plus 4 I1, I2 equal to 36.
36, okay.
I2 will cancel in both the equations.
You are adding the two equations.
Yeah, you will get 23 I1 equal to 36.
Okay. 23. 23. I1 is equal to 36.
Plus 6.
36 plus 6.
Yes. Both equations add 1.8.
Yuvashri, you got the answers? You solved this one? Okay. Parshita, Shri, Shweta, Dishita,
I'm doing one.
Devadarshan.
Working on that.
Yeah. Devadarshan. Devadarshan.
Yes, ma'am.
Oh. You got Yogit? So what did we cover today? We derived Wheatstone bridge balancing condition. I2 is? I2 is minus 0.13. This is positive. So what is the direction of current in I1? Sorry, 1 ohm. I2 is negative, which means it is not flowing from E to F, it is moving from F to E. F to E. Just. Good. நான் உங்கள்கிட்ட நிறைய வாட்டி சொல்லியிருக்கேன் இந்த மாதிரி ஸ்லாண்டிங்காக எழுதுறது, என்னமோ ஸ்கிரிபிள் பண்ணி வைக்கிறது. இப்போ இதான் எக்ஸாம்க்கு பென்சிலில் யூ ரைட்டிங் இன். Yashwant, are you really interested? Are you coming for the class seriously? இல்லை இந்த போர்ஷன் எப்போ நடத்துகிறாங்களோ அப்போ படிச்சுக்கலாம் தான். What about you? Same. You don't know the concept. இவ்வளோ நேரம் சொல்லிக்குவேன். ஏன்னா இவ்வளோ கொஸ்டின் சால்வ் பண்ணும் அப்போ கூட அது புரியலையே உனக்கு டைரக்ஷன். கரண்ட் சிம்பிளாக பாசிட்டிவ் டெர்மினல்லேருந்து நெகட்டிவ் டெர்மினல் போகும், அது புரியுறதா? ஆமாம் கரண்ட்டு. அப்புறம் வேற என்ன வேணும்? இவ்வளோ நேரம் சும்மா தான் உட்காந்துருந்தியா இத்தனை கொஸ்டின் சால்வ் பண்ணும்போது? See, are you serious about your studies? என்ன? They will take this again for you. ஒன்று 6 to 7 வந்து உங்கள் போர்ஷனை முடிச்சிருக்கணும், அதுவும் முடிக்கல. இல்லை இதையாவது ஃபாலோ பண்ணணும். அப்போலேருந்து சொல்லிட்டு இருக்கேன். How many times should I warn you? நிக்கில் எல்லாம் போட்டியா? யூமா? See, it is not a joke, okay? இப்படியெல்லாம் சிம்பிளாக இருக்கிற இந்த சர்க்கியூட்டை கூட ஃபாலோ பண்ணலை, நான் இன்னும் காம்ப்ளெக்ஸாக வந்தாலும் நீ என்ன பண்ணுவேனே தெரியாது. ஏன்டா சும்மா டைரக்ஷன் தான் எடுத்துகிட்டு இருக்கோம். டைரக்ஷனில் நம்ம எடுத்துருக்கிற டைரக்ஷன்லேயே தான் ஆரோ இருக்குன்னா பாசிட்டிவாக எடுத்துருக்கோம். என்ன ஃபார்முலா? Tell me for this loop A, E, F, D, A. சொல்லுடா. A, E, F, D, A. சொல்லு. You can take in either anti-clockwise direction or clockwise direction, whatever. அவங்களே anti-clockwise direction போட்டிருக்காங்க. அங்கே ஒரு arrow தெரியுதா? I1 minus I2 தான் current flow ஆகுது. Then start from there. அது எதுக்குள்ள போகும் அந்த current? எந்த resistance வழியா போகும்? 3 ohms வழியா போகும். So 3 into bracketல within brackets, it's very simple. 3 into I1 minus I2. Then tell me, இந்த டைரக்ஷன்ல ஆன்டி கிளாக்வைஸ்ல சூஸ் பண்ணா நான் I2 எந்த டைரக்ஷன்ல ஃப்ளோ ஆகுது? ரிவர்ஸ்ல ஃப்ளோ ஆகுது. So 1 into minus 1 into I1 I2. Then நெகட்டிவ் பொட்டன்ஷியல்ல இருந்து பாசிட்டிவ் பொட்டன்ஷியல் போற 6 வோல்ட்டுக்கு லோவர் பொட்டன்ஷியல் டு ஹையர் பொட்டன்ஷியல். ஸோ என்ன பண்ணும்? +6 -6 ஏன் -6? If it is flowing from negative to positive, tell me, Nikhil. 6க்கு positive 6 -6 anti-clockwise. A, E, F, D, A. Yes. +6. Negative to positive. Anti-clockwise எடுத்திருக்கோம் I1 minus I2. நீ இப்படி எடுத்தோன்னா அப்போ 3க்கு மைனஸ் போட்டியா? 3 ohmsல போற 3 ohmsல என்ன கரண்ட் ஃப்ளோ ஆகுது? 3 ohmsல என்னடா 3 ohmsல என்னடா கரண்ட் ஃப்ளோ ஆகுது? ஆன்சர் வந்துருச்சுங்கிறது விஷயம் இல்ல. 3 into I1 minus I2 கரெக்டா தானே போட்டிருக்க? 6க்கு என்ன போட்ட? +6 is equal to 0, அந்த பக்கம் -6. கரெக்ட் தான். See, either follow your portions or common portion. That portion நீ 6 o'clock வந்திருக்கணும். ஒரே நாளெல்லாம் இல்ல. You're missing a lot of days. Yeah, thank you all of you. Thank you. You got the answers, all of you? You want the answer? I1 is 1.83 and I2 is negative, which means that current is not flowing from E to F, it is flowing from F to E. Equivalent resistance. That's all. Equivalent resistance இதுக்கு சொல்லுங்க பார்க்கலாம். எது series, எது parallel? 6 and 3 are in series. Series. 6 plus 3 is 9. Then 9. 1 by 9 plus 1 by 9. 9 by 2. 4.5. 3. So 7.5 ohms. Okay, thank you, ma. Any other doubts? I'll send the notes. Wheatstone Bridge புரிஞ்சது இல்லையா? Online students. Yeah. They will take the list signature from you that you have got.